Hello, everybody. Great to be here. Great to have you all here. So today I'm going to talk about what we see as kind of the next evolutionary step, next generation decentralized cloud and DePIN platforms. So very easy to start with. Like this started all ago. Obviously, you can argue that Bitcoin itself is kind of a DePIN, but of course, never back in the days, nobody talked about it. Where this all started really is then in this what we call phase 2 with Filecoin and some others, Akash a little bit later and so forth. What we see as a lot of supply-focused DePINs. So basically, DePINs in these days started building hardware networks with a tremendous success, right? And it was a lot of bootstrapped hardware in the beginning. Some still focus on consumer-grade hardware. Some have already enterprise hardware. Most of these DePIN networks that started there were all focusing on one single use case, storage or compute in the case of Akash, Helium, some others, and so forth. And that's even before anybody was still coining the term DePIN, but this is kind of the starting point of this. Then this phase 3, where just recently, I would say, a couple of years ago, DePIN started also to think about what about the demand side, right? So in the end, this is only going to work if we have real-world products, if we really sell to end customers. And yeah, so by now you have several hundreds DePIN projects already, probably close to 1,000, 50 billion market cap from the Messari report that came out beginning of the year, and they keep on updating this, so this is really great in conjunction with EV3. Also, in this phase, you saw the first really DePIN specialized VCs coming along, and a lot of DePIN networks are trying to ask more the question, can we get customers, enterprise customers, into our networks and really ramp up revenue? Of course, in order to do this, you need a lot of product development, and that really takes some time. And we are at the brim of really now entering phase 4, really challenging the cloud. And of course, this will take some time, but this is where we foresee the future is going. So really challenging the hyperscalers, the AWSs of the world, the Googles and the Microsofts and so forth, really challenging them down the line with enterprise-grade hardware, networks that are really capable of serving many, many different use cases, and make this accessible for enterprise customers, multi-service. What does it take to really get there, and where are the differentiators? So if we compare very briefly centralized cloud service providers against Web3 service providers, and also if we make the comparison a little bit against like the first wave of the DePINs and where we see the future is going, of course on the Web3 side you have a lot of Web3 advantages. Is this the reason why we are all here, right? So privacy, data sovereignty, no single point of failure. So lots of advantages that decentralization brings. And centralized cloud service providers, they don't have it. Also like this win-win opportunity, really building an ecosystem together, really having lots of projects integrated and also sharing the overall value is not happening in the CSP space, and that's of course a lot of a big part of the critics that's coming along with it, like this oligopoly that is really dominating everything there. The multi-service architecture, from our perspective, is a really, really important step, where at the moment DePINs are not really there yet. If you think about this from a customer perspective, of course, the lock-in effect of the central cloud providers is so big because you can just have one place, you go there and you have storage, compute, all types of computes from EC2 to CDN. Like AWS has like 250 services, and that's pretty compelling to a lot of customers. And along the lines, this is needed in the future to make DePIN successful as well. You need somehow to make this offering to enterprise customers and have these multi-services at hand to use. Otherwise, a lot of customers will not switch. Enterprise-grade hardware, of course, is super important. It's tremendously hard. I would say it's not doable to build out of just commodity laptop PCs or whatever a real sustainable enterprise-grade product. And for that reason, we think we should focus a lot on enterprise-grade hardware. Once these networks are built, maybe you can add other hardware as well. But the requirements for enterprise customers are pretty high, and that's the reason why you need certain type of hardware. And then Vuk also talked about like how to access the market, the demand side a little bit. The tooling that's needed to access the demand side is really intensive. So there's a lot of stuff that you need to put in place. Otherwise, you will not attract any customers, right? So for all different use cases, there's a lot of software tooling needed. And that's the goal, what we try to build, not of course by ourselves, but we try to build an ecosystem where a lot of other projects can really plug into. Basically, a multi-service platform for any type of cloud service with super high performance. Compliance is for enterprise customers super important. I talked about it. And that will really have, from the get-go, customers and substantial real-world revenue. I'm going through the stack here, step by step. This is just like how we see this in very easy terms, but basically, you need to have, if you have the customers on top, you need to have the full stack with all different services and protocols and so forth in between, all the way down to the hardware. And there's a lot of stuff that needs to really come into play. Otherwise, you won't have a successful product. But let's run through the swim lanes one by one here. So the first part, enterprise customers. I mentioned this a couple of times now, why we said from the beginning we want to focus on enterprise customers. I think in the long run for the cloud, this is by far the much larger revenue potential, of course. And this is something where AWS has its profit center mainly, and this is what needs to be attacked, right? And then, of course, the requirements getting into this space is super tough, but once you're in that space, the competitive advantages are pretty big. Also, the whole ecosystem flywheel in the enterprise space is super big because you have lots of other companies that you can cooperate with. And believe me, there are many, many out there, also in the Web 2 world, companies making a few billion revenues who really want to win together against the hyperscalers because they're all threatened by the very big tech companies. On the lower right, you basically see the amount of hardware that is needed just based on the AI trend right now. So the additional hardware that's needed just for serving all the AI workloads. And basically it breaks down always into like network, compute, and storage. And these three components are needed at massive scale, obviously, in the next years. But somehow you need to orchestrate this in the right way. The second layer that is super important in order to really get to customers and customers' demand, and without this demand, nothing will happen in the future, what we call market access tools. Of course, every DePIN at the moment that is trying to get to demand is developing it by themselves. We did the same thing. And it's a lot of stuff, right? So you need everything from the security layer and IAM systems, identity and access management, into other parts of firewalling and logging and observability tools, also some CRM tools in order to onboard customers like partner portals and so forth. Also in that layer, what's super important, if you are trying to sell products in the cloud industry, it's a super well-developed ecosystem with many partners, integration partners, distribution partners, lots of companies around the world, as mentioned before, who make like a couple billion revenues. These are partners that we integrated already, that you see here on the slide, and partners that are for any DePIN in the future, I think, necessary if you want to really go for enterprise customers, right? Probably depending definitely on the vertical, on the service that you're offering. So potentially for storage, some partners might look a little bit different on the integration side than for computational jobs and so forth. But basically, if you want to really address enterprise customers, you need to integrate with a lot of these tools. And that's also one of the ideas here in the future. Why not have an ecosystem where not everybody is building again and again the same stuff, but maybe where you can share certain things that have been built once, right? So potentially offering these market access tools also for other DePIN projects that really want to go big on the demand side. So they don't have to build it all themselves, but they can more focus on the software layer, for example, below. Then there is like this big service layer, right? So where you have multiple services, as discussed, like AWS offering around 250 services right now. We started deliberately with storage. Storage is kind of a foundational layer, one of the 3 foundational layers that you always need for any kind of job. And it's a hard one to do because the data has a lot of gravity. So usually it's much more efficient to do a computational job where the data is. So basically you move the computation to the data and not the other way around, which is called like this data gravity. Moving data is super expensive. But of course you need a lot of other services in order to be attractive for enterprise customers. And that's also where we are planning to open up this ecosystem now. So on the object storage side, there are a lot of customers using our product already. So like 20 million files being uploaded every day, probably 100 million by Q3 or so. But it's just like a tiny little piece. I think in the end, it's supposed to be an ecosystem here where other DePIN projects can really build additional services. Like let's say, Vux talked about GPU AI, for example. So basically, you need on the software layer, probably some PyTorch and some TensorFlow and some Ray maybe, and then you build on top through the market access tools, and you have a product basically for the customers. And I think that's the beauty of Web3. We can build things together. And that's the way how we can dethrone the large hyperscalers. So basically adding a lot of services in this layer. And then a lot of the magic is happening on the 2 layers below, what we call the Impossible Cloud Virtual Machine and the Impossible Cloud Network Protocol. So the virtual machine basically is a cloud runtime that orchestrates the hardware that is supplied into the network. So basically it's fully programmable, where service providers can program and access the hardware that is on the very bottom layer here. Basically 4 components. I'm not going into all the details here, how this is done. But ultimately, this is enabling the service providers, other DePIN services and so forth, to access the hardware, the provisioning, and everything that's needed. On the protocol layer, the protocol is basically a node coordination and network formation protocol. So it has an incentivization layer, of course, a tokenomics built in it, and kind of a marketplace between the hardware and the customer. and like with pretty typical things in place where you have like also collateral and so forth for the hardware providers. Maybe one thing to mention here on the tokenomics side. So there are of course different tokenomics needed for different services. Just to illustrate like the tokenomics very briefly here for hardware on the for a storage class. So basically what you might not expect, but depending on the utilization, of course, the reward is increasing up to a certain point, and then it's decreasing. Why? Obviously, when you have a lot of storage in your node and it's utilized like 80–90%, you want hardware providers to add more capacity, right? So otherwise they would be full, and this would be not ideal. So. But these types of incentivizations are built into the network protocol, depending on the service here. And one additional part of the network protocol, which is kind of interesting, is the approach in terms of verifying that the job that is done is correct. So this is, I think, it's coming from A16Z or whatever, this DePIN verification problem. Where you always have kind of a problem how to prove secure compute or how to prove storage that the hardware provider is really doing the job as supposed to be. And we tackled this in an evolutionary approach. So we started very traditionally with SLA contracts, so real-world contracts in place that you can audit and so forth. Of course, on top of that, there is some collateral that hardware providers can get slashed. And then the next evolutionary step from our side will be SLA, what we call SLA oracles or watcher nodes, validation nodes that we will release in the network pretty soon. And they can do all kind of verification jobs. But also what we want to have in the ecosystem here is what we call bring your own proof. As you know, there are a lot of DePIN projects that are developing a very, very specialized proof for a certain problem, right? So for a certain machine learning problem or for a certain other problem. And the idea is, again, let's build this together. I don't think there will be one network that is building all the different proofs. I think it makes a lot of sense to be here in an open ecosystem where other DePIN projects can bring their proof and then access their hardware in a certain way where according to the proof, hardware providers might get slashed or not, or rewarded, right? So this is a big part of it. And in this whole layer, especially on the Impossible Cloud Virtual Machine, we are expecting a lot of open source community starting to grow, where I think a lot of places to really make this all happening. And then on the very bottom layer, you have the hardware providers. Yeah, I mentioned the data gravity before, why I think being close to the storage is pretty important. I think a lot of other stuff is important here as well. So having the hardware, the storage in the right geolocation, for example, in the right compliance, the right data centers with the high performance, the networking, connectivity is super important, so we are always looking to operate out of tier 2, tier 3 data centers in like the big hubs of like Frankfurt, Amsterdam, or US East Coast, and Ashburn, for example, and so forth, where the big internet hubs are. So this really helps to build the network at speed. And this is where we are looking for also like onboarding more and more hardware providers now. GPU as the next class obviously is super interesting, but yeah, I think from here it will grow quite a bit. And before I close, maybe as a summary, on the left side, a little bit like to illustrate how we see this future happening. So what you can see on the left side on the bottom is like the central Web 2 cloud providers. Basically, it goes from left to right, like from single servers like Dropbox, Backblaze, Wasabi, so forth, to the right side where you have a really holistic cloud offering with like multi-services and so forth. This is all done in a very central approach, of course. And then you see on the Web3 side emerging, which I think is super great, since several years now, mainly a lot of very focused single service offerings in the storage space, a lot of stuff happening in the GPU compute space, other spaces as well. And what we see in the future as the holy grail kind of is the top right corner, where Web3 needs to develop into in order to really get mass adoption to the DePIN ecosystem, right? So basically what we want to achieve is connecting like different services together to have a holistic multi-service cloud offering in a decentralized way. And I think the more we get there, the more of the market, the Web2 market also, enterprises will move and use this technology and move away from the bottom right corner, the hyperscalers. So let's partner, let's build this together, and yeah, I'm really excited about this future. Thanks.
Fantastic. Thank you, Kai.